Hello everyone. Here it's a Math Olympiad challenge which is both elegant and surprising. The question says 3 raised to the power of x equals x raised to the power of 9, and our task set is find the value of x. At first glance, this question looks impossible because the variable appears both as an exponent and also as the base of a power. Now let's solve this together step by step. As solution, the first thing is whenever you see this type of equation, make sure you understand what the equation is all about. The equation says 3 raised to the power of x equals x raised to the power of 9. Note that the left side is an exponential function while the right side is a polynomial power. Now let's test for small integer values, starting with simple values. The first thing is, let's try if x equals 1. Our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals 1. So we have our left side as 3 raised to the power of 1, while our right side 1 raised to the power of 9. 3 raised to the power of 1 is 3, and 1 raised to the power of 9 is 1. That means our result on the left side is greater than our result on the right side. That means x equals 1 doesn't work for this equation. Now let's try if x equals 2. If x equals 2, our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals 2. So we have it as 3 raised to the power of 2 equals 2 raised to the power of 9. 3 raised to the power of 2 means 3 times 3, which will give us 9. While 2 raised to the power of 9 will give us 512. That means our result on the left side is less than our result on the right side. So x equals 2 as well doesn't work for this equation. The next thing, let's try if x equals 3. Our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals 3. So we have it as 3 raised to the power of 3 equals 3 raised to the power of 9. 3 raised to the power of 3, that is 3 times 3 times 3, will give us 27. While 3 raised to the power of 9 will give us 19,683. At the end of the day, our result on the left side is less than our result on the right side. That means x equals 3 as well doesn't work for this equation. Now let's try a negative value. That is, if x equals minus 1. Our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals minus 1. So we have it as 3 raised to the power of minus 1 equals minus 1 raised to the power of 9. 3 raised to the power of minus 1 means 1 divided by 3 equals minus 1 raised to the power of 9 will give us minus 1 because the exponent here is an odd number. If the exponent is an even number, then our result here will be positive. But because the exponent is an odd number, that's why our result is a negative number. The result on the left side is greater than the result on the right side. So x equals minus 1 doesn't work for this equation. Since 3 raised to the power of x is greater than 0 for every real number, that means the right hand side must also be positive. So if x is less than 0, then x raised to the power of 9 must also be less than 0. Now let us try the natural logarithm of both sides. Our equation again, 3 raised to the power of x equals x raised to the power of 9. The natural logarithm of both sides will give us natural logarithm of 3 raised to the power of x equals natural logarithm of x raised to the power of 9. Using the logarithm rule, x times the natural logarithm of 3 equals 9 times the natural logarithm of x. Now let's rearrange this, which will give us natural logarithm of x divided by x equals natural logarithm of 3 divided by 9. By the time you cross multiply this, you arrive at this back. The next thing is, let's analyze the function. That is, function of x equals natural logarithm of x divided by x. Since natural logarithm of 3 divided by 9 is smaller than the maximum value, then the equation has two positive solutions. Now let's find the first solution. Let's try if x equals root 3. Our left side again, 3 raised to the power of x, which will give us 3 raised to the power of root 3. While our right side, which is x raised to the power of 9, will give us square root of 3 raised to the power of 9. Square root of 3 means 3 raised to the power of half raised to the power of 9, which will give us 3 raised to the power of 9 divided by 2. Since the square root of 3 is equal to 1.732, then our left side will be 3 raised to the power of 1.732, while our right side will be 3 raised to the power of 9 divided by 2, which is equal to 3 raised to the power of 4.5. Now we can see that our result on the left side is less than our result on the right side. So if x equals square root of 3 does not work for this equation. Now let's look for a value that satisfies x times natural logarithm of 3 equals 9 times natural logarithm of x. Using numerical methods, the first solution is x equals 1.15097. A is our first solution. Now let's find the second solution. In order to find the second solution, let's try if x equals 27. Our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals 27. So our left side will be 3 raised to the power of 27, while our right side will be 27 raised to the power of 9. Since 27 raised to the power of 9 can also be written as 3 raised to the power of 3 to the power of 9, which is equal to 3 raised to the power of 27. Can you see that on our left side we got 3 raised to the power of 27, and on our right side we got 3 raised to the power of 27. That means these two are now identical. So x equals 27 is our second solution. Now let's verify if our x is correct. Let's verify. Our equation again, 3 raised to the power of x equals x raised to the power of 9, where x equals 1.15097. So we have our left side as 3 raised to the power of 1.15097, while our right side will be 1.15097 raised to the power of 9. Using our calculator, 3 raised to the power of 1.15097 will give us 2.715, and also using our calculator, 1.15097 raised to the power of 9 will give us 2.715. Can you see now that our left side is equal to our right side? So in conclusion, x equal to 1.15097, which is our first solution, and x equals 27, which is our second solution. That means you can either make use of any of these values. Thank you for watching.